In this lesson, we're going to graph polar equations, and we are familiar with graphing equations with rectangular coordinates where we put in values of x and we find values of y, and we can graph those. And in the previous lesson, we talked about r and theta as points on a graph. Well, now we're going to choose values of theta to find values of r, and then we can plot those points like we did in the last lesson. So let's start by plotting points with 2 cosine theta. So we have theta that we're going to choose, and then we're going to find 2 cosine theta. So if we choose some theta values, and then we just evaluate 2 cosine theta. So here, at 0, cosine is x over r, and the x value is 1, r value is 1. So this is going to be 2 times 1. At pi over 6, the x value is radical 3, r value is 2. At pi over 4, we get the x value of 1 and the r value of radical 2. At pi over 3, the x value is 1, r is 2, and I'm just copying the 2 from the original equation. At pi over 2, the x value is 0, r is 1, and 2 pi over 3, the x value is negative 1, r is 2, and at 3 pi over 4, we have negative 1 over radical 2. So then let's simplify and approximate. And then we just graph these like in the previous lesson. We need to have, let's go all the way to 3 pi over 4. So we have the pi over 4s and the pi over 6, pi over 3, 2 pi over 3, 5 pi over 6. Looks like we're going out to 2 is the maximum. So we have to go from 1, go out to 1 and 2, and so let's plot the points. At 0, we'll go to 2. We rotate 0 and have a radius of 2. Then we rotate pi over 6 and go out 1.72. Here's pi over 6, 1.72. Pi over 4, 1.42. At pi over 4. Let's go to pi over 3 and go out 1. And at pi over 2, we'll go to 0. So we've followed that. And when we go to 2 pi over 3, at 2 pi over 3, we're going to reflect back to a negative radius. So go to a negative pi over 4. And if we kept on going, we would see that form, and it forms a circle. do the same thing. You can use all the same x values or theta values. So go ahead and try that one. Pause the video. So let's think of it as cosecant, remembering that it is r over y, and we want to have negative r over y. Oh, and just in the previous problem, let's make sure that this is cosine, but we also had to multiply by 2. I just noticed that. So that could be confusing. Just go like that. Alright, so at 0, we want the y value, and that is 0. So we're going to have 1 over 0, undefined. At pi over 6, we need the r of 2, radius is 2, and the y value is 1. So we get negative 2. Pi over 4, the r is radical 2 and the y is 1. So we get approximately negative 1.4. Pi over 3 is up here. We need the r of 2 and the y of radical 3. At pi over 2, radius is 1 and y is 1, so we get negative 1. R is 2, 2 over radical 3. Here we're going to have negative r over y, negative 1.4 approximately. And at 5 pi over 6, it would be radius of 2 with a y of 1, negative 2, and all the way to 2 pi. We could just go to pi. At pi, radius is 1 and y is 0, so that's undefined. And we have to go out to 2. Alright, we're going to, at 0 it's undefined, we don't have a point there. Pi over 6, we're going to go to negative 2. Rotate pi over 6 and go out negative 2. Rotate pi over 4 and go to negative 1.4. Pi over 4, negative 1.4. Pi over 3, I didn't get the decimal for that one. Pi over 2 is at negative 1. Pi over 2 to negative 1. And at 3 pi over 4, we go to negative 1.4. And at 5 pi over 6, we go to negative 2. So that forms a horizontal line. Alright, so that's the long way of graphing using a table. We can also graph using symmetry. We can talk about symmetry to the polar axis. This is the pole, this is the polar axis. And if we had something symmetric to the polar axis, it might look like this. It's the same on both sides of the polar axis. Symmetry to the line, theta equals pi over 2. So if we have the polar axis, here's the line, pi over 2, and we might have something that looks like that, where it's the same on both sides of the line pi over 2. And then we can have symmetry to the pole. So here's the pole, and something that's symmetric to the pole it does look like that, or could look like that. If you see this, it usually has cosine. If you see this, usually has sine. And this, we don't see it very often. It's going to be sine squared and cosine squared. All right. Another strategy in addition to symmetry is the maximum radius. If we have r equals sine theta, max of sine is 1. We can go to 1 or negative 1. And that's just going back to what does the graph of sine look like? It goes up to 1 and down to negative 1. Here, sine and cosine have a max of 1 and a min of negative 1. So we could say that the max r is going to be when cosine is 1, that would be a plus b. As long as a and b are positive. So, well, it really just depends on what a and b are. Rather than relying on steps and formulas, you just rely on, I know this could be the largest cosine it can be is 1, and the smallest is negative 1. What happens if I put a 1 in there? Do I get a maximum value? Or if I put a negative 1, do I get a maximum value? So let's do some examples. So we'll look for symmetry to the line pi over 2 because it's sine. If it were cosine, we'd look for symmetry to the polar axis. The maximum radius. That's going to be the maximum value of sine is 1, so we could say we're going to have 1 plus 2 times 1, 3. What if we had sine of negative 1? 1 plus 2 times negative 1 equals 1 minus 2 is negative 1. This occurs when sine equals 1. This used to be, so the original equation is 1 plus 2 sine theta. Well, sine theta can be 1. When is sine theta equal to 1? Well, that's at pi over 2. Over here we get sine theta equals negative 1. That happens at 3 pi over 2. Alright, and then let's graph these, and if necessary, we just fill in the missing points with a table. Alright. We know the symmetry should be on either side of this line. The maximum radius occurs at pi over 2, and that radius is 3. And we also have at 3 pi over 2, we have a radius of negative 1. So if you rotate to 3 pi over 2, you'll be at negative 1. And it's a little hard to see, well, I guess maybe impossible to see what the graph looks like. So why don't we fill in some points? Let's try 0. We already know pi over 2, but we'll review that. Pi, 3 pi over 2. 1 plus 2 sine of 0. Sine of 0 is 0, so that equals 1. 1 plus 2 sine pi over 2. Sine of pi over 2 is 1, so we get a 3. 1 plus 2 sine pi. Sine of pi is 0. That's negative 1, which we already did up there. So at 0 we go to 1. At 0 we go to 1. At pi over 2 we go to 3. At pi we're back at 1. And then we're going to go back up there. With more plotting of points, we would see this happening. Okay. Do as much as you can. Pause the video and do as much as you can, then take a look at what I did. So if we have cosine, we would expect polar axis symmetry. And that means when we're looking at the graph, we want to see something that's symmetric on both sides of the polar axis. The maximum R. R is a maximum if you put a 1 in place of cosine. And that would give you 6. When do you get a cosine of 1? When does cosine equal 1? Remember that 1 over 1, x over r, we want an angle that has an x value of 1 with a radius of 1. Well, that's right there. It happens at 0. So we have to go all the way out to a radius of 6. We know there's a point there, and it's symmetric, so it looks like it'll be on top and bottom of the polar axis. And let's just plot some points. So we have cosine of 0 is 1. And then we're going to have cosine of pi over 2 is 0. Cosine of pi is negative 1. And cosine of 3 pi over 2 is 0. Okay, so 0, 6, we have that. Pi over 2, we're going to go to 2. At pi, rotate to pi, go to, and then go negative 2. So we're not rotating the pi and staying at 2. We're rotating pi and going back to negative 2. 3 pi over 2, we're at 2. So we see the same shape happening there. And last example. Graph using symmetry. Pause the video and try that. Since we have cosine, we would expect symmetry to the polar axis. And let's look at the maximum radius. The maximum radius which value of cosine gives the maximum radius? Well, cosine could be as big as 1 or as small as negative 1. If I put a 1 there, then the radius is 1. If we put a negative 1 there, then the radius is 5. So the maximum radius occurs when cosine is negative 1. When is cosine equal to negative 1? Cosine equals negative 1 when x is negative 1, and that gives us pi. So in the graph, we have, so far we're going to rotate to pi. At pi, we have a radius of 5. So that means there's a point there. Let's look at some other points. I forgot 0. Alright, 0. And we're doing r equals 3 minus 2 cosine theta. So this is 3 minus 2 cosine of 0. Cosine of 0 is 1. 3 minus 2 equals 1. 3 minus 2 cosine 3 pi over 2. Cosine of 3 pi over 2 is 0, so we get 3. 3 minus 2 cosine of pi. Negative 1 times negative 2 is positive 2, and that's where we get the 5. And 3 minus 2 cosine pi over 2. That's 0, and we get 3. So let's see how these points look. At 0, we'll be at 1. At 0, we're at a radius of 1. Going in order, at pi over 2, we're at 3. At pi, we're at 5. So we're starting here and going like that. Now we're at 3 pi over 2. We go back to 3. At 3 pi over 2, we're at 3. And the graph looks like that. All right, we'll stop there.